Dear students, we shall discuss about inverse trigonometric functions. In the previous class, we solved some problems of 2-mark questions. Today, we shall solve some more problems on inverse trigonometric functions. This also 2-mark question. Sometimes asked, prove that sin inverse 4 by 5, which is equal to cos inverse 3 by 5. Cos inverse 3 by 5. Here, LHS sin inverse 4 by 5, which is converted into cos inverse 3 by 5. First, we take, let sin inverse 4 by 5 is equal to theta. Then, sin theta is equal to 4 by 5. This means sin inverse 4 by 5 is equal to theta. Then sin theta is equal to 4 by 5. Now, here, it's theta. Sin theta is opposite side by hypotenuse. Then by triplets of Pythagoras triplet, we can conclude it is equal to 3. Then cos theta is equal to 3 by 5. Then cos inverse theta is equal to cos inverse 3 by 5. Here we can conclude theta is equal sin inverse 4 by 5 is equal to theta. Then cos theta is equal to cos inverse 3 by 5. Therefore, sin inverse 4 by 5, which is equal to cos inverse 3 by 5. It's the proof. First, we convert sin inverse 4 by 5 into cos inverse 1. First, let us take sin inverse 4 by 5 is equal to theta. Then sin theta is equal to 4 by 5. Then we represent theta in terms of cos trigonometric function. Cos theta is equal to 3 by 5. Then theta is equal to cos inverse of 3 by 5. Here, from 1 and 2, we get sin inverse 4 by 5 is equal to cos inverse 3 by 5. In the same way, we can convert it into tan inverse form also. It is tan inverse. We can write tan inverse, which is 4 by 5, because 4 by 3. 4 by 3 is the tan inverse form. We convert this into tan theta is equal to 4 by 5. Then convert theta is equal to tan inverse of 4 by 5. It may be converted in different inverse trigonometric functions like this. In the same way, you can convert another problem second. Prove that, it's a 2-mark question. Prove that tan inverse 5 by 12, which is equal to sin inverse of 5 by 13. Here, in the LHS, tan in a tan tan inverse pi by 12 which is equal to theta. Then tan theta is equal to pi by 12. Here also we take right angle triangle. It's theta. Theta is equal to tan theta is equal to opposite side by base is equal to 12 for adjacent side. Then it's equal to 3 because 12 square plus 5 square which is equal to 13 square. It's hypotenuse. Therefore, we can convert it into sin theta. Theta is equal to tan inverse of pi by 12. Then sin theta. We taken it into tan theta. Sin theta is equal to opposite side by hypotenuse pi by 13. Therefore, theta is equal to sin inverse of pi by 13. Therefore, tan inverse of pi by 12 which is equal to sin inverse of pi by 13. Pi by 13. Tan inverse of pi by 12 which is equal to sin inverse of pi by 13. The same way we can convert it into cos inverse form also. Cos inverse is equal to 12 by 13. 12 by 13. CT question also will come on this type. You should carefully find the other inverse trigonometric functions like sec, cosec inverse also. This is the one more problem I will tell you here. It's the given this property or formula in the inverse trigonometric functions cos inverse x, cos inverse of 1 minus x square divided by 1 plus x square where x is greater than or equal to 0. Here we take tan inverse x equal to y. Tan inverse x is equal to y or theta. Tan inverse or x equal to tan y. X equal to tan y. Now cos RHS, cos inverse of 1 minus x square divided by 1 plus x square which is equal to cos inverse of 1 minus tan square y. Yeah, I replace x by tan y. Then 1 plus tan square y. Yeah, 1 minus tan square y divided by 1 plus tan square y is equal to cos 2y. Therefore, it is equal to cos inverse of cos 2y. Then cos cancel, which is equal to 2y. Here 2y is equal to 2 into y like that tan inverse of x. Tan inverse of x. Here put tan inverse x equal to y. We substitute x value becomes x equal to tan y. We substitute this value in the RHS. Cos inverse of 1 minus x square divided by 1 plus x square. Cos inverse of 1 minus tan square y divided by 1 plus tan square y divided, which is equal to cos inverse of cos 2y. It's the formula of 1 minus tan square y divided by 1 plus tan square is equal to cos 2y. It's the trigonometric identity. Then cos cancelled is equal to 2y is equal to 2 tan inverse x. Therefore, 2 tan inverse x equal to cos inverse of 1 minus x square divided by 1 plus x square. 1 plus x square is this problem. Okay, root. Then now we shall go to the 3-mark questions which are asked on this chapter. It's the maximum marks asked in this question paper, in the question paper is 3 marks. Therefore, 3-mark questions. I will discuss 3-mark questions. First one is write the function tan inverse of root 1 plus x square minus 1 divided by x where x is not equal to 0 in the simplest form. In the simplest form. Here we simplify tan inverse of square root of 1 plus x square minus 1 divided by x in the simplest form by taking some trigonometric functions as x. Here tan inverse of root 1 plus x square minus 1 divided by x. Here we put tan inverse of x is equal to theta or tan theta is equal to x. X equal to tan theta. Put x equal to or x equal to tan theta. Therefore, it becomes LHS or the function is becomes tan inverse of 1 plus tan square theta square root divided by tan theta minus 1. 1 plus tan square theta is equal to secant square theta. Therefore, is equal to tan inverse of secant square theta, yeah, square root of secant square theta divided by tan theta, which is equal to tan inverse of, here also minus 1 is there, minus 1. Tan inverse of secant square theta square is tan theta minus 1 divided by tan theta. Here we put tan inverse is in the tan theta in form of sin theta by cos theta. Here is the sec theta. Sec theta minus 1. Square root of sec square theta is equal to sec theta minus 1. Put in the form of sec theta is 1 by cos theta minus 1 divided by sec theta divided by cos theta. Cos theta is the denominator, which is equal to cos theta. In the numerator is 1 minus cos theta divided by cos theta. Sin theta by cos theta, which is equal to tan inverse of, which is equal to tan inverse of cos theta gets cancelled. Then 1 minus cos theta divided by sin theta, which is equal to tan inverse of 1 minus cos theta is 2 sin square theta by 2. 2 sin square theta by 2 divided by sin theta is equal to 2 sin theta by 2 into cos theta by 2. Sin theta by 2 divided by cos theta by 2. Then square is cancelled. Sin square theta by 2 is here. 1 sin square sin theta is cancelled. 2 cancelled. Then is equal to tan inverse of tan theta by 2. Because sin theta by 2 divided by cos theta by 2 can cancel. theta by 2, which is equal to theta we taken here is equal to tan inverse of x. Therefore, we write it as tan inverse x divided by 2 or 1 by 2 into tan inverse x. We don't write it tan inverse of x by 2. Tan inverse of x by 2, which is equal to 1 by 2 into tan inverse of x. 1 by 2 into tan inverse of x, not tan inverse of x by 2, not tan inverse of x by 2. It's theta is equal to theta by 2 is equal to 1 by 2 tan inverse x. 1 by 2 into tan inverse x is the answer. Here simplification is very here, but put tan inverse x theta is a very important factor here. Put tan inverse x or tan theta is equal to x only, we can solve this problem. 1 plus tan square theta is equal to secant square theta. We can put the trigonometric identity here. Okay, so easily when simplify very easily. Then next problem. I taken here is it's a more different. Input sin inverse of 1 minus x minus 2 sin inverse x, which is equal to 5 by 2. Find the value of x. Find the value of x. Here, taking LHS or simplifying these two, finding the x value. Therefore, we taken the equation as it is sin inverse of 1 minus x minus 2 sin inverse x, which is equal to 5 by 2. Here, I taken 2 sin inverse x left RHS side, sin inverse of 1 minus x, which is equal to 5 by 2 plus 2 sin inverse x. I taken minus 2 sin inverse x from LHS side to RHS side. It becomes plus 5 by 2 plus 2 sin inverse x. Then sin inverse of 1 minus x, which is equal to 1 minus x equal to sin inverse form. I taken sin inverse as RHS side. It becomes sin of 5 by 2 plus 2 sin inverse x. You already know about sin of 90 plus theta or minus theta. Yeah, sin 90 plus theta or minus theta is cos theta, but it is in the second quadrant. Second quadrant sign is positive, therefore it is equal to cos theta. Therefore, it is equal to cos of theta here is 2 sin inverse x. 2 sin inverse x. Therefore, 1 minus x equal to cos of 2 sin inverse x. Then we find here, it is in the form of 1 minus x is equal to cos of 2 sin inverse x. Cos of 2 sin inverse x in terms of sine form, we get 1 minus x is equal to 1 minus 2 sin square sin inverse of x, because cos 2 theta is equal to cos 2 theta is equal to 1 minus 2 sin square theta. Cos 2 theta, which is the identity used in the first PO class, already studied you. Cos 2 theta is equal to 1 minus 2 sin square theta. 2 sin square theta. Here 1 minus 2 sin square theta is there here. Therefore, it is equal to cos 2 sin inverse x. 2 sin inverse x. Cos 2 theta is equal to theta is equal to sin inverse. Here theta is equal to here it's theta, here 2 theta, here theta is equal to sin inverse of x. 2 1 minus 2 sin square theta, here 1 minus 2 sin square sin inverse of x. Sin inverse of x equal to here theta, therefore which is equal to cos 2 theta, cos into 2 into theta is equal to sin inverse of x. Therefore 1 minus x equal to this one, therefore x equal to cos 2 theta 2 sin inverse x. Here it's in the form of 1 minus 2 sin cancel, we get here is 1 minus 2x square, 1 minus 2 sin x square. Cos 2 sin inverse x is in the form of 1 minus 2 sin square into sin x. Sin into sin x gets cancelled, it is equal to 1 minus 2 x square. We put this one comes here, 2x square minus x. Here it comes here, it's 0, 2x square minus x equal to 0. By taking all from to LHS side, 2x square x, taking common x, 2x minus 1 which is equal to 0, then x equal to 0 or x equal to 1 by 2. Here put in x equal to 1 by 2 is not satisfy the equation, because sin inverse of 1 minus 1 by 2 minus 2 sin inverse x, which is equal to sin inverse of 1 by 2 minus 2 sin inverse of 1 by 2. It's not equal to pi by 2. Therefore, we don't take this variable. Therefore, taking 0, sin inverse 1 minus 0 is equal to sin inverse of 1. Minus 2 into sin inverse of 0 is equal to 0 here. Therefore, sin inverse of 1 is equal to pi by 2 and this is equal to pi by 2. Therefore, satisfy the equation when x equal to 0 only. Therefore, 0 x equal to 0 is the answer. It's the not satisfy the equation. In this problem, we use trigonometric identity like cos 2 theta is equal to 1 minus 2 sin square theta, and one more is pi by 2 plus 2 sin inverse. Sin inverse 1 minus x equal to pi by 2 plus 2 sin inverse x. 1 minus x equal to it becomes sin inverse is becomes here sin of pi by 2 plus sin inverse x. It becomes sin 90 plus theta is equal to cos theta. It's in the second quadrant, it's positive. Therefore, 1 minus x equal to cos of 2 sin inverse x. Then 1 minus x equal to 1 minus 2 sin square sin inverse x is equal to cos 2 theta. Here it is equal to cos 2 theta. Here theta is equal to sin inverse x. Cos 2 theta is equal to this one. Cos 2 theta is equal to 1 minus 2 sin square theta. Therefore, 1 minus x equal to 1 minus 2 into sin square is equal to sin square. Theta is equal to sin inverse x. Then sin gets cancelled. It becomes 2x square. Sin square means here 2 of square. Sin inverse square means sin of sin inverse x whole square. Sin square theta here, not theta square. Sin of sin inverse x whole square. Therefore, sin gets cancelled. Here x is there. Therefore, is equal to 2x square. Then 2x square minus x equal to 0. By simplifying this one, we get x equal to 0 and x equal to 1 by 2. But 1 by 2 is not satisfy the equation. Therefore, we take x equal to 0 is the solution of this equation. Therefore, find the value of this x is x equal to 0. In this chapter, in 2 more type of questions are there. I will solve that one. Yeah. Show that sin inverse 3 by 5 minus sin inverse of 8 by 17 which is equal to cos inverse of 84 by 85. Here, show that sin inverse of 3 by 5 minus sin inverse of 8 by 17 is equal to cos inverse of 8 by 84 by 85. Here, LHS side, it's in the sin inverse form, but in the RHS side, it's in the cos inverse form. We are adding these two. Some more examples or formula are there, but if I will here solve this problem by simply taking sin inverse of 3 by 5 which is equal to taken as x. Then sin x is equal to 3 by 5 and convert it into cos x also. Cos x becomes here 3 by 5, so opposite side by hypotenuse is equal to 4 is equal to x. Then cos x is equal to 4 by 5. Then the same way sin inverse 8 by 70. 8 by 70 which is equal to y. Then 8 by 17 which is equal to or sin y is equal to 8 by 17. In the same way cos y is equal to we write the y angle in the different triangle because y is different here. 8 by 17 is the opposite side, 17 is the hypotenuse, then it is equal to 15. So using Pythagoras triplet we can conclude 15, because 17 square minus 8 square, which is equal to 225, which is equal to 289, minus 64, which is equal to 225, 225. Therefore, square term is equal to here hypotenuse, the sides, this side, which is equal to 15 square. 15. Therefore, 15. We conclude cos y is equal to 15 by 70. 15 by 70. Then we put these in the LHS like cos of, because here is cos inverse, therefore I taken here cos of sin inverse 3 by 5 minus sin inverse 8 by 17, which is equal to cos of a minus sin a minus sin, first cos of, okay, sin a minus sin b is equal to here sin inverse of here equal to I will take here, don't take here, cos of sin x and cos x here, cos of x minus y, okay, x minus y is equal to cos of x minus cos a minus b is equal to cos of x cos of y, then plus sin of x sin of y. You already studied in the first few class. Cos x minus y is equal to cos x cos y plus sin x sin y. If it is plus, here it is minus. Here cos x minus x is equal to sin inverse of 3 by 5 and y is equal to sin inverse of 8 by 17. But here cos x equal to 4 by 5. Cos x equal to 4 by 5. Cos y is equal to 15 by 17 plus sin x is equal to 3 by 5. Then sin y is equal to 8 by 17. Then is equal to 4 by 5 into 15 by 7. 17 by 5 is equal to 85 is equal to 60 plus 8 into 3 24 divided by 85. Therefore, the answer is 84 divided by 85. Therefore, it is equal to cos of x minus y is equal to 84 divided by 85. Therefore, x minus y, which is equal to cos inverse of 84 divided by 85. Here, x and y I taken here is sin inverse of 3 by 5 minus sin inverse of 8 by 17, which is equal to cos inverse of 84 divided by 85. This is the sin inverse of minus 3 by 5 minus sin inverse of 8 by 17, which is equal to cos inverse of 84 divided by 85. Here I taken here sin inverse 3 by 5 is equal to x and sin inverse 8 by 17 is equal to y. Then I convert sin x and sin x and sin cos x is equal to 3 by 5 and 4 by 5 respectively. In the same way, I find sin y and cos y also by using right angle triangle, using Pythagoras triplet. Then we find this one. I substitute this cos x and cos y value in the cos of x minus y. Cos of x minus y. I only represent here x minus y, but I taken here is cos because here is the cos inverse. If it is sin inverse, we take here cosine one. Therefore, I take here cos of x minus y is equal to cos x minus into cos y plus sin x into sin y. To substitute these values in this equation, we get 84 by 85 is the cos of x minus y. Therefore, x minus y is equal to cos inverse of 84 by 85. Then we then put the LHS side is equal to RHS, which is the steps involved in this problem. It will ask on 3-mark questions. Then one more question is there. It's to find the value of x. Find the value of x in the given equation. We'll solve that type problem. Fourth one. Solve tan inverse 2x plus tan inverse 3x, which is equal to 5 by 4. Is equal to 5 by 4. This question is many times asked in the annual question paper. Therefore, you should practice this problem. LHS and RHS will be taken here is let us tan inverse 2x plus tan inverse of 3x, which is equal to 5 by 4. You already know about the formula tan inverse of x plus tan inverse of y, which is equal to tan inverse of x plus y divided by 1 minus x into y. By using this formula, we write it as tan inverse of 2x plus 3x divided by 1 minus 2x into 3x, which is equal to 5 by 4. Then we simplify this one. 5x divided by 1 minus 6x square. Then I tan inverse taken this side, tan of 5 by 4. Then tan by 4 is equal to 1. Tan 5 by 4 is equal to 1. Tan 45 is equal to 1. Therefore, 5x divided by 1 minus 6x square, which is equal to 1. 1. Therefore, 5x is equal to 1 minus 6x square. Then I taken here 6x square plus 5x minus 1, which is equal to 0. Then solve this by 6x square minus plus 6x minus x minus 1 is equal to 0. 6x minus 1 is equal to plus 5x. 6x into minus x equal to minus 6x square. Then taken as 6x x plus 1 minus 1 x plus 1, which is equal to 0. Then 6x minus 1 and x plus 1, which is equal to 0. Then 6x minus 1 is equal to 0 or x plus 1 is equal to 0, x equal to minus 1 or x equal to 1 by 6. Here x minus 1 is not satisfy the equation here. It's equal to minus 1. Tan inverse of minus 1 is not satisfy the equation, but x equal to 1 by 6. 1 by 6 is equal to 1 by 6 is equal to 2 by 3. 1 by 3 and tan inverse of 3x is equal to this much. We can satisfy the equation by x equal to 1 by 6 only, but it is negative, it's not possible. Therefore, x equal to 1 by 6 is the answer here. Only the solution. In the same way, we can find another problem like this type. If tan inverse of x minus 1 divided by x minus 2 plus tan inverse of x plus 1 divided by x plus 2 is equal to 5 by 4. This is also the question many times asked in the question paper. Sometimes alternative question paper, this type question will ask. This is 3-mark question. Here also we can take LHS, this tan inverse of x minus 1 divided by x minus 2 plus x plus 1 divided by x plus 2 divided by 1 minus x minus 1 divided by x minus 2 into x plus 1 into x plus 2. This is equal to 5 by 4. We taken tan inverse that side is equal to tan 5 by 4 is equal to 1. In the numerator, all steps you should write x plus 2 into x minus 2, which becomes x square minus x square. Then x plus 2 into x minus 1 is equal to x square minus plus x 2 into minus is equal to minus 2 plus x plus 1 into x minus 2 is equal to x square minus x minus 2. Then in this case x square minus 4 minus, it's multiplied this one, x square minus 1 divided by x square minus 2 square. This one is gets cancelled. We get x square plus x minus 2 here. Here x gets cancelled. X square minus 4. X square minus 4 divided by here x square minus of minus x square. Minus 4 minus x square is minus x square is plus 1, which is equal to 1. Then x square minus 4 divided by x square is cancelled, minus 4 is equal to minus 3 is equal to 1. Then x square minus 4 which is equal to minus 3. Multiply these to this one and this is x square minus 4 is taken that side, minus 3 plus 4. Here is 2x square, I think x square plus x square is equal to 2x square. Therefore, 2x square is equal to plus 1. Therefore, x square is equal to 1 by 2. Therefore, x equal to plus or minus square root of 1 by 2 is the answer. Therefore, we can write it as x equal to plus or minus 1 by root 2. Here, simplification is very important. To substitute this value is not, you can using formula, you can substitute easily. But simplification, you should solving this. Don't forget the sign. By changing the sign, you made some small mistake. We can't get the value of x correctly. Therefore, simplify this question is very important. And using this solution, I use the x minus 2 and x plus 2 formula, and using brackets here, then only you multiply minus to the 2% x square and minus 1, then only you get the same answer of x equal to exponent root of 1 by 2 or x equal to plus or minus 1 by root 2. I think solve our type of problems. I will give one more problem like prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 which is equal to cos inverse of 33 by 65. I will tell you simply the steps involved in this problem. You can solve yourself only. Here, it's in the cos one. Here also cos one. You can use the formula one in the given in your book also. Otherwise, you can solve cos inverse x equal to a and is equal to b. Then cos of a is equal to 4 by 5 and cos of b is equal to 12 by 30. Then sin a is equal to which is equal to 3 by 5 because of the trigonometric reflex. Then cos sin b is equal to 5 by 30. Here also 12, 13 and 5 by the word reflex. This is 3, 4 and 5. You should remember some Pythagoras method to solve the problem easily. Then sin A, sin B also given here. Then we take here cos of A plus B. Cos of A plus B which is equal to cos of A into cos of B minus, it's a plus, we take anyways, minus sin B into sin B. Then we get cos A is equal to 4 by 5 into cos B is equal to 12 by 30 minus sin A is equal to 3 by 5 and cos 5 is equal to 5 by 30. You get the answer here is 4 by, here I didn't write cos of, then cos of cos, here is not cos, then we take the plus. Here 4 by 12 into 4 is equal to 48 divided by 13 into 5 is equal to 65 minus 15 divided by 65. Cos of A plus B which is equal to this one. Therefore, A plus B is equal to cos inverse of 48 minus 15 is equal to 33 divided by 65. Therefore, A plus B is equal to, we taken here is cos of A plus B is equal, cos of A is equal to cos inverse 4 by 5 plus cos inverse divided by 13, taken here is cos inverse 12 by 30 which is equal to cos inverse of 33 by 65. Therefore, to solve all type of problems you have to face in the examination of in trigonometric functions of 3-mark questions. I already solved 1 mark, 2 mark and 3 mark questions in inverse trigonometric functions. You yourself you solve these problems and practice well. It's very easiest problems to get good marks in the examination. Thank you.